From the tiniest fleeting particles to the grand cosmic web that stretches across billions of light years, our universe is a story of unimaginable scale and breathtaking complexity. It's a story that began not with a bang in the conventional sense, but with an instant of pure, hot, dense energy, an event we call the Big Bang. In that first fraction of a second, the universe was a seething soup of fundamental particles. Quarks, electrons, photons, the building blocks of everything, collided and annihilated in a dance of creation. The four fundamental forces we know today, gravity, electromagnetism, and the strong and weak nuclear forces, were once unified, a single perfect force governing an infant cosmos. As the universe expanded and cooled at an incredible rate, these forces split apart, each taking on its unique role in shaping reality. Within minutes, the temperature dropped enough for quarks to bind together, forming the first protons and neutrons. For the next 380,000 years, the universe was an opaque, glowing fog of charged particles and light. Photons were trapped, endlessly bouncing off electrons, unable to travel freely. This was the cosmic dark age, a universe filled with light, yet one from which no light could escape. Then, a pivotal moment arrived. The universe cooled sufficiently for protons and electrons to combine, forming the first stable atoms, mostly hydrogen and helium. Suddenly the fog cleared, the photons were set free, and for the first time, light could travel unimpeded across the cosmos. This ancient light, stretched by the expansion of space over 13.8 billion years, is still detectable today as the cosmic microwave background, a faint, lingering echo of the universe's birth. With the universe now transparent, another force began to dominate the stage: gravity. It's a patient, relentless force. Over hundreds of millions of years, gravity began to pull on the slightly denser regions of the hydrogen and helium gas clouds left over from the Big Bang. These were tiny imperfections, quantum fluctuations from the first moments of time, now amplified into the seeds of cosmic structure. Slowly, almost imperceptibly, these clouds began to collapse inward. As the gas compressed, the pressure and temperature at the core of these massive clumps skyrocketed. The atoms were squeezed together with such incredible force that they began to fuse. Hydrogen nuclei slammed into each other, forging helium and releasing a tremendous burst of energy. In this moment, the first stars were born, igniting the darkness and flooding the young universe with brilliant light. At the center of these disks, second and third generation stars ignited, stars like our Sun, and around them, in the swirling debris of the disk, something new began to form. Dust grains stuck together, growing into pebbles, then rocks, then planetesimals, and finally, full-fledged planets. Rocky worlds formed closer to the new star, while gas giants took shape in the colder outer regions. Our own solar system is a direct descendant of this cosmic recycling program. On a grander scale, gravity was sculpting entire galaxies. The first small, irregular galaxies, rich in gas and newborn stars, began to merge. Pulled together by their mutual gravitational attraction, They collided and danced, their stars and gas clouds swirling into magnificent spiral and elliptical shapes. These galactic mergers triggered furious bursts of star formation, lighting up the cosmos. Over billions of years, these galaxies themselves were not isolated. They were drawn together by gravity into massive clusters and superclusters, separated by vast, empty voids. Looking out into the universe today, we see this grand structure, a cosmic web of filaments and nodes with galaxies strung along them like pearls on a string. Every point of light is a galaxy, home to billions of stars, a testament to gravity's patient architectural power. But there's a twist in our cosmic story. In the late 20th century, astronomers observed that the expansion of the universe, which had been slowing down due to gravity, was actually starting to speed up. Something was pushing the universe apart, counteracting gravity's pull. We call this mysterious force dark energy, and it makes up nearly 70% of the universe. We don't know what it is, but its effects are profound, determining the ultimate fate of our cosmos. And there's another mystery: dark matter. We can't see it, it doesn't interact with light, but we know it's there because we can see its gravitational effects on the stars and galaxies we can see. It acts as the invisible scaffolding of the universe, providing the extra gravitational pull needed to hold galaxies and galactic clusters together. Together, dark matter and dark energy make up 95% of the universe. Everything we can see, every star, every galaxy, every planet, is just a tiny 5% of the total cosmic inventory. So here we are, on a small rocky planet, orbiting an average star, in a spiral galaxy that's part of a supercluster, adrift in a vast, accelerating universe. We are made of stardust, forged in the hearts of long-dead stars. The iron in our blood, the calcium in our bones, the carbon in our DNA, all were created in stellar explosions billions of years ago. The cosmic story is our story. From the simplest particles born in the Big Bang to the intricate web of galaxies, it's a narrative of transformation, of simple beginnings leading to incredible complexity. And it's a story that's still being written. Every time we look up at the night sky, we are looking back in time, seeing light that has traveled for millions or even billions of years to reach us. We are witnessing the ongoing saga of cosmic evolution, a universe still unfolding, still full of mystery, waiting to be explored. Thank you for joining us on this journey through space and time. If you found this as fascinating as we do, don't forget to like, subscribe, and hit the notification bell for more explorations into our incredible universe.